We now determine the component form as well as the magnitude of each of these 8 given vectors. When the vector u and vector v are given as these vectors, vector u is basically written in component form as 3 comma minus 2, and vector v is written in component form as negative 2 comma 5. Notice that the formula or the component form of a vector is given as like this. That is, it basically represents the vector represented in terms of the components, that is x component and y component, where we utilize this triangular brackets, and the magnitude of the vector is given as a square root of x squared plus y squared. Okay, so we now do the component form and the magnitude of the first vector. That is, we are going to consider the first vector 3u. So first calculate the 3u. So this is basically a scalar multiplication of a vector u, where the scalar quantity is 3. So first you put the 3 over here like this, and then put the vector u in its component form, that is 3 comma minus 2. So this basically means we have to distribute the 3 to the inside component forms, that is the components. So when we do that, we have to multiply 3 with the 3. 3 times 3 is 9, and 3 times minus 2 is 6. Negative 6, it's in fact. So we have to represent like this. This is the component form of 3u vector. Now let's calculate the magnitude of 3u vector. We can represent the magnitude as like this, either in single vertical bars like this or in double vertical bars like this, and this is equivalent to, we can replace this 3u vector, which we have already found in component form. So I'm going to replace, which means I consider x as 9 and y as negative 6. I'm going to substitute in this formula, that is a formula for magnitude of a vector, which means I have to take the square root, and x here is 9, so therefore I have to square the x, which means it is 9 squared, plus y here is negative 6, so I have to square it like this. You can put a parenthesis to avoid any kind of mistakes. So this is equivalent to 9 square is 81, and negative 6 square is basically 36. It's a positive number, so this is what we are getting. So this is equivalent to 81 plus 36 is 170, square root of 170. So this is the magnitude of 3u vector. Let me quickly erase this, and we can move on to do the next question. The second vector that we are going to do is for negative 2v. We are going to do this one. So this is equal to minus 2v equal to, I put the scalar minus 2 as it is, and then I substitute the v vector. It is minus 2 comma 5. Now I have to do the distribution minus 2 with these two components. So minus 2 times of minus 2 is positive 4, and minus 2 times of 5 is minus 10. It's a negative number. So this is the component form of minus 2v vector. Now let's find the magnitude of the negative 2 vector. So I'm going to write like this, with vertical bars, double vertical bars like this. I can replace this minus 2v vector, which we have already found out, which is x equal to 4 and y equal to negative 10. So let me find the magnitude of this vector using this formula, which is x square plus minus 10 square under the root. We have to take the square root. So this is equal to 16. Negative 10 square is 100. This will be equal to 116. We can try to simplify this. So this is basically 58 times of 2, and this is equivalent to 29 times 2 times 2, which means I can write down this as I have 2 in pairs, so I can take it out of the square root. So I can basically write down this as 2 root 29. So this is the magnitude of negative 2v vector. Let me remove this. Let's now do the third one, that is u plus v vector. This is basically addition of two vectors u and v vector. So let replace the u vector. This is 3 comma minus 2, and plus v vector is minus 2 comma 5. So this is going to, we have to add the components by components. We have to add the 3 with negative 2 and minus 2 with 5. That is, the x component should be added with x component and y component should be added with y component. So this basically gives, we can put it in triangle brackets, 3 minus 2 is positive 1 and minus 2 plus 5 is positive 3. So this is the component form of u plus v vector. Now let's find the magnitude of u plus v vector. So we can write down like this. So then you have to consider this as x and this as y. So I'm going to use the same magnitude formula. It's square root of x squared plus y squared, which is 1 squared plus 3 squared, and this is equivalent to 1 plus 9, and this is equal to square root of 10. So this is the magnitude of u plus v vector. Now let's do the next one. Being the fourth one, that is u minus v vector. This is equivalent to, we have to substitute the u first. That is 3 comma minus 2, and then minus 2 comma 5. So here we have to subtract the vector v from u vector, which means I have to do the component by component subtraction. 3 minus 2, that is 3 minus of minus 2 is basically 3 plus 2, and minus 2 minus 5, this will be minus 2 minus 5, and this gives 5 comma minus 7. This is the component form of u minus v vector. Now let's find the magnitude. So we consider this 5 as x and negative 7 as y. So using the formula, we will get 5 squared plus minus 7 quantity squared. This is equal to square root of 5 squared is 25 and minus 7 quantity square is 49. So when we add these two together, we'll be getting 74. So this is the magnitude of u minus v vector. We now find the next vector, that is the fifth one, 2u minus 3v vector. Let me get this erased. We have 2u minus 3v. So this is equivalent to, we have to put the 2 first and then the v vector, which is 3 comma minus 2. We have minus 3 times of v vector, that is minus 2 comma 5. So first let's distribute the 3 with the, let's distribute the 2 like this. We have to multiply. 2 times 3 is 6. This is equal to 6. 2 times minus 2 is minus 4. This is our first vector. Plus, I am going to put plus because I'm going to multiply this negative 3 inside the numbers. So negative 3, negative 2 is positive 6. And this is negative 3 times of 5 is negative 15. So now we can consider this as something like a vector addition. 6 plus 6 is 12. And minus 4 minus 15 is minus 19. So this is a component form of 2u minus 3v vector. Now let's find the magnitude of 2u minus 3v vector. Consider 12 as x and minus 19 as y. So therefore we can use the formula for magnitude, and when we do that, we get 12 square plus minus 19 quantity square. We have to put this under the square root. So this is equivalent to 12 square is 144 and 19 square is 361. When we add this, we get 505. So this is the magnitude of the fifth vector, that is 2u minus 3v vector. Let's now do the same thing for the remaining three vectors. That is, we now do the sixth vector. This is minus 2u plus 5v. So I put the minus 2 first and then replace the u vector, which is 3 comma minus 2 plus 5 times of v vector is minus 2 comma 5. So this gives, I have to do the distribution like this. Minus 2 times of 3 is minus 6. Minus 2 times of minus 2 is positive 4. I could have put this as just 4. Let me remove this. It's just 4. Plus 5 times of minus 2 is minus 10. 5 times of 5 is 25. So basically we just have to add these two vectors, which is minus 6 minus 10 is minus 16 and 4 plus 25 is 29. This is the component form of minus 2u plus 5v vector. Now let's find the magnitude. This is minus 2u plus 5v. So we have to consider the x as negative 16 and y as 29, which means when we use the formula, it will be minus 16 square plus 29 squared. So this gives, this is basically 1097 square root. You can further simplify this, or you can just approximate this to some decimals, which is coming as 33.12. This is approximately. So this is the magnitude of the sixth vector, minus 2u plus 5v vector. Now let's do the component form of seventh vector. And we have 3/5 u vector plus 4/5 v vector. So first let's find out this 3/5 u vector. I put the 3/5 and then replace the u vector, which is 3 times of minus 2. I'm sorry, it is 3 comma minus 2 plus 4 5 v vector, which is minus 2 comma 5. So first let's do the distribution. We have to distribute the 3/5 with the 3 as well as the minus 2, and when we do that we will get 9/5 minus of 6/5 plus, here I have to do the distribution of 4/5 with 2 and minus 2 and 5. So when I do that, I'll be getting minus 8/5 comma, it's basically 4, but I'm going to write down as 25th. This will help us to do the addition a little bit easy. So now we have to add these two vectors, that is 9/5 should be added with the negative 8/5 and minus 6/5 should be added to 25th. And when we do that, we'll get 9 minus 8 is 1/5 and minus 6/5 plus 25th is 14/5. So this is the component form of the vector 3/5 u plus 4/5 v. Now let's determine the magnitude of this vector, that is magnitude of 3/5 u plus 4/5 v, which means I'm going to consider the 1/5 as x and the 14/5 as y. So when we substitute into the magnitude of vector, we get 1/5 quantity square plus 14/5 quantity square, and this should give us square of 1/5 is 125 and square of 14/5 is 196 by 25. So let's get this simplified. So this is equivalent to 197 by 25th square root. We can write down this as a square root of 197 divided by 5, because square root of 25 is 5. So this is the magnitude of the given vector, that is for the 7th vector. To the 8th vector, we have minus 5 by 13u plus 12 by 13v. So first let's do this. So this is going to get us minus 5 by 13 times of u is, I have to replace the u, which is 3 comma minus 2, plus 12 by 13. V is basically minus 2 comma 5. So let's find the component form. So I have to do the distribution of minus 5 by 13 with 3 comma minus 2. And when we do that, we get minus 15 by 13 comma 10 by 13. Minus 5 times of minus 2 is positive 10. So this is basically 10 by 13. Similarly, we have to do the distribution of 12, 13 with minus 2 and 5. And when we do that, we'll be getting minus 24 by 13 comma 12 times 5 is 60 by 13. Now we just have to add the two vectors, that is corresponding components. So we have to add minus 5 by 13 with 24 by 13, minus 24 by 13, and 10 by 13 with 60 by 13. So since the denominator is the same, we can just add only the numerators, which is minus 15 minus 24, and this is equal to minus of 39 by 13. And for the second, that is for the y component, we have 10 plus 60 is 70 by 13. So this is equal to, we can further simplify this, minus 39 by 13 is minus 3, and 70 by 13. This is the component form of the 8th vector, minus 5 by 13 u plus 12 by 13 v. Now let's determine the magnitude, so which is minus 5 by 13. We have minus 5 by 13 plus 12 by 13 v. We find the magnitude, so we put them in double bars like this. So here I have to consider this negative 3 as x and 70 by 13 as y, which means if I use the formula, I have to use minus 3 square plus 70 by 13 quantity square, and this is under the square root. So this will give us minus 13 minus 3 square is 9 plus 70 by 13 square. This is 4900 divided by 169. We can get this added. So this will be we get 6421 by 169. And this is approximately 6.16. And this is the magnitude of the minus 8th vector, that is minus 5 by 13u plus 12 by 13v.